So remember we said filled in arrows are line ends. The larger hollow arrows are loads. So if I click on this, if I just left click on my hollow arrow, it's going to bring up my load feeder dialog window. The load feeder dialog window has two tabs. It has a load tab and a feeder tab. They're all the same, and all of the loads have one feeder, which is named F1. And from here you have a fair amount of control. From here you can enable or disable an entire feeder. So if I wanted to shed all of the load from this feeder without de-energizing it, I would uncheck the enabled, I would hit my apply, and I would watch all of my Auburn A load go away. Now you'll notice there was a load value here of about 40 megawatts. And then some amount of ours, about 18 probably. Now as soon as I disabled that entire feeder, all of that shifted to the cold value. So the current value is simply how much load is currently being served through that feeder at this moment, and the cold value is essentially what's left. So since I have disabled this entire feeder, I can actually see that this cold load is going to build up over time. So we were at about 40.4, and now we can see that we're at 41.4 and rising. So as I bring this load back, if I brought back the entire feeder, it would be whatever the value of this cold load value is. The nominal is not really something that will be too concerning. Pretty much what you want to focus on are the current output and the cold value. So if I disable this entire feeder, I'll see this cold load value build up over time. In the simulator, when you bring loads back in, you will not see the initial inrush of energizing compressors and things like that, but what you will see is the dynamic effect of the returning load diversity over time. So as you bring back portions of feeders, you will see they will be brought back at a higher value, and you will see that taper off. So the longer this feeder is de-energized, the more this cold load value will build up. So let's say that I'm gonna re-enable this feeder, but I'm only gonna bring 40% of it back. So if I set this value at 40, if I don't want to bring the entirety of it back on all at once, which, you know, when you're either in an islanded or a restoration type condition, that can be very important, particularly because some of the feeders are quite large. Because we don't have distribution modeled in Cascadia, a feeder is essentially an aggregate of the load that's being served in a particular area of the system. So in this case, you know, the Auburn A sits at about 40-some megawatts. Some feeders are quite small. At the Spokane station, they were about 5 megawatts. But if you go to the Seattle station, they're very large. They're about 600. So this is a way that you can control the amount of load being brought back by simply slowly increasing this percentage. And you'll see that that value comes from whatever the cold load value is. So had this cold value been much higher, you would see that taper off, which is important again in a restoration, for example, when you have to keep an eye on your frequency. This also works the other way. We'll bring back all of the load. This is also handy. So if you're in a normal state where all of your load is being served, and you actually need to remove a portion of a load, and Cascadia has some remedial schemes for that. If you want to remove a portion of a load, remember this is a percent enabled. I'm going to do it from the feeder tab. It does the same thing, but this is a percent enabled, so a percent of the whole. So if I want to shed 20% of this feeder, I'm going to change my enabled percent to 80, hit apply, and then observe the effects. I can tell, there's a couple of ways that I can tell that this feeder has not been entirely brought back on. I can still see that there is cold load attached to here. So I know that this is probably not at 100%. So if I click on my F1 tab, this is going to show me exactly where I am. So if you haven't been able to keep track of of your loads as you're changing them. That's okay. There's also a table that we'll use to show that too, but we'll talk about that in a different video. So I will be able to see, even though when I first opened up my feeder dialog, I couldn't tell. As soon as I click on the F1, I can see exactly what my percent is. The other thing that you can do from the feeder tab is you have the ability to add non-conforming megawatts and megavars. If you do that, there might be some exercises that call for you adding non-conforming megawatts or megavars in a particular area to basically concentrate the load. It works a little differently than in real life. Essentially, the definition of non-conforming is that it doesn't follow a load pattern, so large industrial customers and things like that. The way that it works in the simulator is it's more of a redistribution of the whole. So as I add 10 megawatts, I'll see that this feeder is now serving almost 55 megawatts, but there are other ones in the system that have been brought down a bit. It's not super important. The biggest thing to remember is if you want to add non-conforming megawatts or megavars, you do it from the F1 tab of your feeder dialog window.